Picture a continent unlike any other on Earth, a place so vast, so remote, and so brutally unforgiving that it exists almost outside of time itself. This is Antarctica, the last true wilderness, Earth's frozen frontier. For centuries, it was little more than a whisper on old sailors' maps, a ghostly rumor at the edge of the known world. Even now, beneath its endless silence and shifting ice, it keeps its secrets well. A land locked away beneath miles of frozen history. Here, in this place of staggering isolation and stark beauty, the ordinary laws of life seem suspended. It feels less like part of our world, and more like another planet entirely. It is a realm of stark, breathtaking desolation, where the very air can freeze your breath. Winds howl across endless plains of white, carving monumental, ephemeral sculptures from snow and ice. Temperatures plunge to unimaginable lows, making it the coldest, driest, and highest continent on Earth. Here, the sun can vanish for months, leaving the landscape bathed in an eerie twilight, or it can circle endlessly, a constant, pale presence above a blinding expanse. No permanent human cities have ever taken root here. No sprawling civilizations have etched their mark upon its surface. Only temporary research outposts dot its fringes, tiny specks of human endeavor dwarfed by the sheer, overwhelming scale of its wilderness, a testament to our struggle against an environment so utterly indifferent to our presence. For most of human history, it has been, and largely remains, untouchable, but this barren landscape, this formidable fortress of ice, is more than just a testament to nature's raw, unyielding power. It is a vault, a colossal deep-freeze archive, preserving a history far grander and more unsettling than we dare to imagine. Beneath its glittering, ever-shifting surface, under miles of compressed snow and glacial weight that has accumulated over millions of years, lies a continent largely untouched by human eyes, a canvas of geology and deep time waiting to be read. What stories are etched into the rock below? What ancient echoes might rebound from its frozen depths, if only we had the means to listen? Now shift your gaze from this present-day desolation. Peel back the layers of ice, not just in geological time, but in your mind's eye. Imagine Antarctica not as the frozen wasteland we know today, but as a land teeming with life. Picture a time, unfathomably long ago, when verdant forests stretched across rolling hills, when lush, unfamiliar vegetation carpeted valleys warmed by a temperate sun. Envision vast, powerful rivers carving through fertile plains, their waters glinting as they flowed into sparkling inland seas, perhaps even a gentle coast where mild breezes carried the scent of exotic blossoms and the calls of unique creatures. This is not mere fantasy. The planet has seen such transformations many times. Scientific evidence already hints at this radically different past, a stark contrast to the continent's current icy shroud. Fossil records uncovered in the relatively ice-free pockets of the continent reveal ancient palm trees, ferns, and even dinosaur remains. These are not just isolated anomalies, they paint a consistent and compelling picture of a continent that was once a vibrant ecosystem, perhaps even a crucial, central part of a supercontinent where life flourished in abundance, rich in biodiversity, sheltered by a mild climate. The very bedrock beneath the ice tells a tale of shifting continents, of tectonic plates moving Antarctica from warmer latitudes, a slow, inexorable dance across the globe that ultimately led it to its solitary, frozen vigil at the South Pole. This geological journey, however, conceals a profound transition, a change that took eons to unfold yet left an indelible mark on everything beneath the surface. But what if this past was not merely geological or biological? What if the life that thrived here was not just flora and fauna, not just simple organisms or ancient forests? What if, in those long-forgotten epochs, before the Great Freeze descended with its relentless grip, there was another story entirely? A story of advanced beings of purposeful design, of a presence that resonates with our deepest questions about existence. Imagine if, long before humanity's first tentative steps on other continents, long before our earliest known cities rose from the deserts and riverbanks of the Middle East, another kind of history was already unfolding on this very landmass. What if, beneath the crushing, silent weight of Antarctica's 2-mile-thick ice sheets, lies not just fossilized forests and ancient riverbeds, but the preserved remnants of a civilization? A society that once thrived in this now desolate land, building structures of immense scale, developing technologies perhaps beyond our current comprehension, and even crafting a culture whose echoes are now tragically silenced by a colossal glacial tomb. This is the unsettling, profound premise we must confront. The idea that hidden under miles of ice, a lost chapter of intelligent life awaits discovery, is more than a thought experiment. It suggests a complex, perhaps advanced civilization that rose, flourished, and then vanished, swallowed by a planetary transformation of epic, almost biblical proportions. It is a thought that fundamentally challenges every established timeline of human history, every archaeological record, every deep-seated assumption about our unique place and late arrival in the grand story of Earth. Could our perceived beginning be merely a continuation, a retelling of a much older tale? If such a civilization ever existed, its remains would be preserved in a way unlike any other on Earth. The deep, constant freeze of Antarctica, coupled with its unparalleled isolation, could act as a perfect vault. It could be entombing its cities, its tools, its accumulated knowledge, perhaps even its art and its very biology, in a state of cryogenic stasis that defies the normal processes of decay and erosion that obliterate so much of our own past. It would be a frozen memory, a time capsule waiting for the right moment and the right advanced technology to be brought back into the light of human understanding. The very thought alters our sense of time. The implications of such a discovery stretch far beyond mere scientific curiosity. They would be revolutionary. They would fundamentally rewrite the story of humanity itself, forcing us to question everything we thought we knew about our origins, our technological progression, and our unique, singular place in planetary history. For as long as we have pondered our existence, we have assumed a linear path, a slow climb from primal beginnings to modern complexity, centered on the familiar continents. But if Antarctica once harbored an advanced society, it would mean humanity is not the first intelligent species to rise on this planet. We would not be the pioneers of civilization, but rather the inheritors of a much older, forgotten legacy. It would shatter the comfortable linear narrative of progress, suggesting instead that cycles of civilization may have risen and fallen long before our own, erased by geological shifts and cosmic forces rather than just historical conquest or internal collapse. Could the legends of Atlantis, of Mu, of other submerged or lost lands be more than myth? Could they be fragmented, distorted memories of a truth hidden for eons? Consider the seismic impact on our understanding of ancient history and mythology. The discovery would not just add a new chapter to Earth's story. It would necessitate a complete re-evaluation of the entire book, from its earliest pages. It would redefine the very concepts of ancient and modern, pushing back the timeline of intelligence and organized society on Earth to an almost unimaginable antiquity, forcing us to reconsider our place in a much longer, more complex tapestry of life. Moreover, such a find would offer profound, perhaps terrifying, insights into the resilience and fragility of both life and civilization. How did they thrive in a world transforming from temperate paradise to frozen hell? What incredible technologies, what ingenious strategies did they develop to cope with impending doom with the inexorable advance of glacial ice? And what lessons, what warnings might their rise and fall hold for our own civilization as we face our own accelerating planetary challenges and confront the very real possibility of environmental collapse? The questions it would raise are as vast and enigmatic as the continent itself, stretching from the deepest, most forgotten past into our most uncertain future. This journey into Antarctica's unimaginable past is not just an exploration of a physical landscape. It is a descent into deep time, a venture into the very fabric of our planet's hidden secrets. It asks us to look beyond the obvious, beyond the surface, and to entertain possibilities that once seemed confined to the wildest realms of fiction. It demands an open mind and a willingness to question the bedrock of our accepted history. We will delve into the geological forces that transformed this once vibrant land into an icy mausoleum. We will examine the subtle anomalies detected beneath the ice, the whispers that have long fueled theories of unusual structures and deliberate patterns. We will explore the cutting-edge technologies that might one day penetrate this frozen veil, and what unique conditions within the ice could preserve evidence across unimaginable spans of time, holding even delicate artifacts intact against the ages. This is not merely a quest for ruins. It is a search for a truth that could redefine everything we believe about our origins. A truth buried under silence, under miles of ice, under centuries of unquestioned assumptions. Antarctica stands as a monument to the unknown, a guardian of secrets that could fundamentally alter our understanding of who we are, where we come from, and what the future may hold for a species that once thought itself alone in its intelligence. Stay with us as we journey into the heart of the world's greatest mystery, because if a civilization once lived beneath the ice, then our timeline is not the beginning at all, but only the continuation of something much older. A story written not in dusty scrolls, but in stone and ice, waiting to be read. And this is where we turn to the next part of the story, the geological journey that transformed a green continent into a frozen enigma. To understand what may lie beneath the monumental ice, we must first journey back through time. Not just millennia, but hundreds of millions of years. For the continent we now call Antarctica was not always a desolate realm of frozen white. It has a story far older, deeper, and more vibrant than its current silence suggests. A geological epic of transformation. Our chronicle begins in an age almost beyond human comprehension. A time when the Earth's land masses were woven into a single, magnificent supercontinent known as Gondwana. Imagine a world where the continents we know today, Africa, South America, India, Australia, and Antarctica, were intimately joined, forming a sprawling, interconnected landmass that dominated the southern hemisphere. Antarctica, in this ancient configuration, was not an isolated outpost at the very bottom of the world, but rather a vital, central piece of this geological puzzle. Its position was far different from its present-day solitude, cradled much closer to the equator, enjoying a climate that bore no resemblance to its current frozen state. For vast epochs, stretching over hundreds of millions of years, this Gondwanan heartland experienced a climate utterly alien to modern perceptions of Antarctica. Geological evidence, etched into the very rocks of the continent, paints a vivid picture of a world teeming with life, where temperate rainforests stretched across vast plains and diverse ecosystems flourished under a mild sky. When scientists speak of a lush Antarctica, it is not hyperbole. Fossil records meticulously unearthed from the few exposed rock formations and even from beneath the receding ice reveal an astonishing botanical richness. Ancient ferns, their fronds delicate yet resilient, carpeted the land. Towering coniferous forests akin to those found in modern-day New Zealand or Chile dominated the landscape, their mighty trunks reaching towards the sun. Even flowering plants, the harbingers of botanical modernity, left their indelible imprints, speaking of a time when nectar and pollen sustained a vibrant insect and animal life. Paleoclimates, reconstructed through a painstaking analysis of these fossilized remains and the isotopes locked within ancient sediments, confirm this astonishing reality. They tell of average temperatures consistently above freezing, of abundant rainfall nourishing sprawling river systems, and of warm, humid conditions that persisted for immense stretches of geological time. This was a land of rivers winding through verdant valleys, of lakes shimmering under a temperate sun, and perhaps even inland seas that offered pathways for ancient marine life. The very air would have been different, rich with the breath of countless plants, a stark contrast to the thin, biting winds of today. This verdant past, once dismissed as a mere anomaly, is now understood as the continent's long, sustained reality. It was a place not just capable of supporting life, but one that actively nurtured it, hosting a biodiversity that would challenge our preconceptions of what is possible at Earth's extremities. This was a continental canvas upon which complex ecosystems, vibrant and resilient, unfolded their intricate narratives over eons. Then, the slow, relentless ballet of continental drift began its profound rearrangement. Driven by the colossal forces churning deep within the Earth's mantle, Gondwana, after its long reign, started to fracture. One by one, its constituent landmasses began to tear away, embarking on their solitary voyages across the planetary surface. First, Africa broke free, drifting northwards. Then, India separated, beginning its epic collision course with Asia. Australia and South America too commenced their long journeys, leaving Antarctica in an increasingly isolated position. This process, a slow-motion geological dance, took tens of millions of years, an unfathomable span of time during which the continent we now know as Antarctica gradually, inexorably, began its slide towards the bottom of the world. As Antarctica drifted south, its climate slowly, imperceptibly at first, began to change. The once temperate land, warmed by its equatorial neighbors and open oceanic currents, found itself at the planet's icy pole. But the true isolation, the moment that irrevocably sealed its fate, came with the formation of the Drake Passage. As South America finally separated from the Antarctic Peninsula around 34 million years ago, a vast ocean channel opened up, linking the Pacific and Atlantic Oceans. This monumental geological event allowed for the birth of the Antarctic Circumpolar Current, a powerful, frigid ocean conveyor belt that began to endlessly circle the continent. This current acted as an impenetrable thermal barrier, preventing warmer waters from reaching Antarctica's shores and effectively locking it in a deep freeze. Suddenly, the continent was not merely at the pole. It was thermally isolated, cut off from the global climate system that had sustained its warmth for so long. With this isolation, the gradual formation of the immense Antarctic ice sheets began. It was not an instantaneous cataclysm, but a slow, creeping transformation, a geological process of unimaginable scale and duration. Initially, glaciers began to form in the continent's highland regions, clinging to mountainsides, expanding with each successive winter. Snowfall accumulated year after year, refusing to melt entirely in the increasingly short and cool summers. These nascent ice caps acted as vast, reflective mirrors, bouncing sunlight back into space and accelerating the cooling process, creating a powerful feedback loop that amplified the chill. Then, approximately 34 million years ago, a significant global climate shift, possibly triggered by a decrease in atmospheric carbon dioxide, pushed the planet past a critical threshold. What had been a gradual cooling accelerated into a rapid, profound glaciation event. The scattered mountain glaciers merged, coalesced and expanded with terrifying speed, cascading down valleys, overwhelming the forests and plains, and burying the entire continent beneath a colossal, relentless sheet of ice. This was the moment of true entombment. The timeline of glaciation shows that this wasn't a static event, but a dynamic, yet ultimately overwhelming process. Over the subsequent millions of years, the ice sheets continued to grow and stabilize, expanding and contracting with natural climate cycles, but never fully retreating. The East Antarctic ice sheet, the larger and more ancient of the two, formed first and has remained remarkably stable for tens of millions of years, a colossal geological fixture. The West Antarctic ice sheet, more dynamic and vulnerable, developed later but still reached monumental proportions. Today, these two vast ice sheets cover approximately 98% of the continent, reaching thicknesses of up to 3 miles in places. Beneath this enormous frozen mass lies the ancient land, silenced and preserved, its verdant past and any history it might contain, locked away in a deep, dark vault. This glacial entombment was a process of unparalleled geological finality. The ice did not merely cover the land, it enveloped it, pressed down upon it with unimaginable weight, transforming mountains into subglacial peaks and valleys into hidden troughs. Rivers were frozen solid, lakes turned into vast, still chambers of ice, and entire ecosystems were pressed into oblivion. The very atmosphere of the continent changed from one that supported lush plant life to the hyper-arid, freezing desert it is today, where precipitation falls mostly as snow and remains frozen for eons. The persistent cold, the immense pressure, and the sheer absence of light combined to create an environment where surface life, as it once existed, could not possibly endure. This transformation was so complete, so profound, that it effectively erased the surface history of an entire continent, burying it under a frozen shroud that has persisted for millions of years. And it is this very act of geological erasure, this deep freeze, that sparks the most compelling questions. For if Antarctica once harbored life, vibrant and complex, perhaps even reaching the pinnacle of advanced forms, then the ice sheets did not merely destroy it, they sealed it away. The continent, once a canvas of green, became a giant natural time capsule, a silent witness to a past irrevocably lost to the surface world. The immense power of the ice, which crushed and reshaped everything in its path, also served as an unparalleled preservative. It captured a moment in time, locking away fragments of a once living world, holding them in stasis for eons. It is this extraordinary geological journey, from a temperate heartland of Gondwana to the isolated, icebound continent it is today, that sets the stage for what might be concealed beneath its unforgiving surface. The ice is not merely a barrier, it is a vault, and within its unfathomable depths, a lost past waits to be rediscovered. The titanic forces of geology and climate eventually shrouded the verdant continent in a glacial tomb. But what if the ice in its vastness holds more than just geological memory? What if it acts as a silent witness, capturing echoes of a past far stranger than simple rock and sediment? For some, the answers to such profound questions may lie in the very anomalies that defy conventional explanation. These are the whispers from beneath, faint signals reaching us from a world long frozen, hinting at a history untold. When scientists peer beneath the colossal ice sheets of Antarctica, they employ technologies designed to penetrate the darkness, ice-penetrating radar, which sends radio waves deep into the glacial mass, and seismic imaging, which uses sound waves to map the bedrock below. Most of the data returned from these powerful instruments paints a picture consistent with natural geology, undulating bedrock, ancient riverbeds carved by water long gone, and the layered accumulation of ice and sediment over millennia. But sometimes the signals defy easy explanation. They present patterns that seem to resonate with a different kind of order, an order that suggests intention rather than mere geological chance. Imagine radar profiles that, instead of showing the expected curves and chaotic folds of rock, reveal uncanny regularities. Straight lines extending for miles, cutting across the natural grain of the landscape. Corners forming precise 90-degree angles where nature typically favors rounded edges. Geometric shapes, almost too perfect, seemingly etched into the subglacial terrain beneath thousands of feet of ice. These are not always easily dismissed as instrument glitches or interpretive errors. For some researchers, these readings become tantalizing riddles. Could such precise formations truly be the product of random geological processes? Or do they hint at something structured, something built, something that once shaped the very land before the deep freeze set in? The scale of these potential anomalies is often immense, suggesting engineering on a truly monumental level. Structures that would have stood as testaments to their creators even against the crushing weight of glaciers. These subsurface patterns revealed by penetrating radar are sometimes seen as too consistent, too uniform, to be merely the result of geological chance. They stand out from the random fragmented echoes expected from a natural, eroded landscape. This raises the haunting question: what kind of natural process could leave behind such distinct, almost architectural blueprints beneath the ice? The possibility lingers that these signals are not merely rock formation, but the deeply buried foundations of something else entirely, something deliberately crafted beyond radar. Seismic data also occasionally delivers perplexing echoes. Sound waves, when reflected off solid objects, create distinct signatures, while most reflections map out known geological strata or bedrock features. Some datasets have shown reflections inconsistent with typical rock formations. These could be denser materials or structures with unusual internal consistency, deflecting sound waves in ways that mimic hollow spaces or deliberate arrangements. It is as if the very bones of the continent, probed by these powerful sonic pulses, are murmuring a secret, a deep, resonant hum that suggests something alien to the slow, organic processes of Earth's crust. Interpreting these subtle variations is incredibly challenging, yet the persistence of such unusual signatures in multiple surveys fuels the imaginations of those who dare to consider a more unconventional past for Antarctica. These seismic anomalies could indicate areas of unusual material density or structural integrity. A natural bedrock typically has a certain range of elasticity and density, which seismic waves pass through in predictable ways. But if the waves encounter something vastly different, perhaps highly compacted engineered materials, or even vast subterranean voids, the reflections would be distinct, almost alien. These deep echoes from beneath the ice become puzzles, urging scientists to look beyond standard geological models. They compel us to wonder if these are not merely geological oddities, but the faint, distorted reverberations of something vast and ancient, a testament to a presence that once exerted control over the very lithosphere itself. This leads us to another intriguing, albeit highly debated, piece of evidence that seems to contradict our modern understanding of Antarctica's icy past: historical maps. For centuries, cartographers and historians have pondered particular artifacts that seem to depict the Earth in ways that should have been impossible for their time. Among the most famous of these is the Piri Reis map. Compiled by an Ottoman admiral in 1513, this map, remarkably accurate for its era, shows the coastlines of West Africa, South America, and the northern coast of Antarctica. What makes this segment profoundly unsettling is its depiction of the Antarctic coast. It is not shrouded in ice as it has been for millennia, but instead shows detailed features of mountains, rivers, and bays, suggesting a temperate climate. Mainstream historical and cartographic explanations for the Piri Reis map generally attribute this accuracy to a combination of lost ancient source maps, possibly from the time of Alexander the Great, and the accumulation of knowledge from earlier explorers. perhaps even some degree of imaginative extrapolation or misinterpretation. They argue that the depicted landmass might not even be Antarctica proper, or that its ice-free state is a coincidental resemblance to modern geological surveys of the underlying land. Yet to those who look beyond the accepted narrative, the Piri Reis map suggests a different possibility. It hints that its ancient sources, perhaps much older than the 16th century compilation itself, documented a period when Antarctica was indeed ice-free. A time when its coasts were charted by unknown navigators, perhaps even from a civilization we have long forgotten. The map's details, which include mountain ranges known only after modern seismic surveys, present a profound challenge to established timelines. How could a 16th century mapmaker, or even his ancient sources, know the precise contours of a continent buried under ice for millions of years? This question gnaws at the edges of conventional history. It implies either an astonishing level of geographical knowledge possessed by a civilization far predating our own, or a truly miraculous act of predictive cartography. The debate surrounding this map is not merely academic. It strikes at the heart of our understanding of ancient human capabilities and the true history of our planet. If this map genuinely depicts an ice-free Antarctica, then the world we thought we knew becomes infinitely more complex, shrouded in layers of forgotten time and lost knowledge. It would mean that at some point, long before recorded history, eyes saw and minds mapped a continent that is now utterly transformed. Posing the silent question, who were those eyes? And what did they build upon those now frozen shores? Beyond the faint radar whispers and the curious historical documents, some observers have noted patterns inferred from geological models or even from surface features that, for them, seem to resist purely natural explanation. When satellite imagery and advanced geological surveys map the subglacial terrain, they often reveal striking forms. While most are undeniably natural, some configurations, particularly those of immense scale, provoke deeper questions. Imagine looking at topographical maps generated from under the ice, showing vast, elevated plateaus, unusually uniform basins, or ridge systems that converge with an almost deliberate precision. These are not necessarily sharp, man-made edges, but rather broad, sweeping outlines that for some hint at a scale of engineering that could reshape entire landscapes. The challenge, of course, is attributing intent to forms seen through miles of ice and millions of years of geological activity. Glaciation itself is a powerful sculptor. Ice flow can erode, deposit, and shape bedrock into surprisingly regular patterns. Tectonic forces can create fault lines that appear geometric, and ancient volcanic activity can leave behind structures that might resemble ruins. Yet, for those who seek alternative explanations, some of these features push the boundaries of what purely natural processes are expected to produce. They speak of a geological uncanny valley, where the forms are almost natural, but something about their scale, alignment, or sheer repetition feels too organized to be entirely random. Consider the possibility of colossal dams now buried and eroded, designed to manage ancient river systems, or vast integrated complexes, perhaps even entire cities, whose eroded foundations now present as a series of unnaturally uniform elevations and depressions beneath the ice. These immense, deeply buried structures, if they exist, would be the ghosts of a titanic effort, their original forms smoothed and distorted by the weight of time and ice, yet still subtly imposing a non-random order on the subglacial landscape. The interpretation of these features remains highly contentious, with mainstream science favoring natural explanations rooted in glacial geology. But for a select few, these patterns represent the eroded, ghost-like imprints of something far more extraordinary, structures that hint at a technological society operating on a scale almost beyond our current comprehension. They suggest a lost form of architecture, one built to withstand not just time, but geological upheaval, echoing the grand scale of the continent itself. This leads us directly into a more speculative, yet profoundly intriguing concept: technosignatures. While biosignatures point to the existence of life, whether microbial or complex, technosignatures are the subtle hints that suggest the presence of advanced technology or engineering. These are not direct sightings of flying machines or power plants, but rather residual effects or indirect patterns that could only be explained by intelligent intervention on a grand scale. Beneath the Antarctic ice, for instance, a technosignature might manifest as an unusual energy signature, a localized heat anomaly that defies explanation by geothermal vents or volcanic activity alone. Imagine a vast, deeply buried structure whose material composition subtly deflects seismic waves in ways inconsistent with natural rock or ice, suggesting an engineered material. Or perhaps traces of elements or compounds found in concentrations that are highly improbable in a natural geological context, pointing to industrial-scale processing or manufacturing. Consider the immense energy requirements of a civilization, even an ancient one. Such activity, even long after its cessation, might leave persistent thermal, chemical, or even electromagnetic imprints. A deeply buried, long-defunct power source might continue to subtly warm its immediate surroundings, creating minute temperature gradients detectable with highly sensitive instruments. Or the degradation of advanced materials might release unique isotopic signatures that stand out against the background of natural Antarctic geology. These are the kinds of clues that, while not outright proof, would compel a shift in scientific thinking, moving from pure geology to a consideration of engineering. The search for technosignatures is about looking for the needle in the haystack, not by directly observing the needle, but by analyzing the subtle disturbances it creates within the hay itself. It's a pursuit of the unexpected, the outlier, the one data point that refuses to fit the natural model, thereby opening the door to a truly astonishing alternative. It is the idea that even after millions of years, the ghosts of grand engineering projects could still subtly influence the physical properties of the continent, waiting for our instruments to detect their lingering presence. These faint signals could be the last remnants of a forgotten industrial past, an advanced society that harnessed energies and shaped materials in ways we are only beginning to comprehend, leaving behind a legacy not of ruins visible to the eye, but of disturbances in the very fabric of the continent. Yet, this quest for traces of a forgotten past beneath Antarctica is fraught with profound challenges. The primary hurdle lies in the immense difficulty of discerning between the hand of nature and the potential works of an intelligent hand, especially when veiled by miles of time and ice. Earth's natural processes are themselves capable of creating formations that can appear remarkably ordered, even artificial, to the human eye. Glacial ice, as it flows and grinds across the bedrock, can sculpt mountains, carve valleys, and deposit sediment in ways that might seem structured. Tectonic forces can produce remarkably straight fault lines, and erosion, driven by wind and water, in Antarctica's ancient past, can shape rocks into smooth edges or even geometric forms. The human mind, wired to find order and recognize patterns, can easily project its expectations onto randomness. A ridge might look like a wall, a cluster of peaks like a city, or a series of depressions like a deliberate arrangement, when in reality they are merely the consequence of forces indifferent to our expectations and intelligence. Furthermore, the scale of geological time involved is staggering. Any potential structures from a lost Antarctic civilization would have been subjected to millions of years of glacial movement, intense pressure, freeze-thaw cycles, and erosion by subglacial water. Materials that might have been durable above ground would be broken down, scattered, or compressed into unrecognizable forms. What began as a grand edifice could, over eons, be reduced to nothing more than a slight anomaly in a radar reading, a subtle variation in seismic reflectivity, or a barely perceptible contour in the bedrock topography. Without direct access, without physical samples, without undeniable markers of construction like tools, inscriptions, or a definitive material composition, Every unusual reading or suggestive shape remains a tantalizing enigma, open to multiple interpretations. Science, rightly so, demands a high burden of proof, favoring the simplest and most common explanations. And in Antarctica, the simplest explanation for an unusual pattern is almost always a geological one. This leaves us in a place of deep uncertainty, where the line between natural grandeur and artificial structure remains blurred, and the whispers from beneath the ice are difficult to definitively translate. Despite the allure of a lost civilization, the immense power and creativity of nature itself often provide perfectly plausible explanations for what might otherwise seem inexplicable, challenging our assumptions and forcing us to confront the limits of our perception and technology. The very vastness and extreme conditions of Antarctica become a shield, both preserving and concealing its deepest secrets, making the search for definite answers an enduring test of human ingenuity and patience. If the echoes of a lost civilization truly lie beneath the frozen continent, then the immense ice sheet that conceals them is not merely a barrier, an impenetrable wall of white. It is also a vault, a remarkable preserver of secrets capable of holding ancient truths in a state of suspended animation. The very conditions that make Antarctica so inhospitable, the crushing cold, the staggering pressure, the profound isolation from the vibrant world above, are precisely what could have created the most extraordinary archaeological site on Earth. Imagine materials, organic and artificial alike, locked away for millions of years in a deep freeze unlike any other. Glacial ice acts as a unique time capsule, shielding its contents from the ravages of time that would normally consume them on a temperate landmass. The relentless cold drastically slows down chemical decomposition, preventing the molecular breakdown that degrades all matter. Within the ice, oxygen levels are incredibly low, almost non-existent in deeper layers, halting the oxidation that rusts metals and rots organic tissues. Furthermore, the sheer weight and stability of the ice sheet create an environment largely undisturbed by earthquakes, wind erosion, or the ceaseless activity of biological life that would otherwise consume or scatter ancient remains. It is a stillness born of extreme cold, a crystalline silence that could keep secrets perfectly intact for epochs. This extraordinary preservative power is not merely theoretical. We have seen its effects in other, smaller, ice-locked environments around the world. On Earth, ice has already delivered astonishing glimpses into the past. Think of the Siberian permafrost yielding mammoths, their flesh, fur, and even stomach contents preserved for tens of thousands of years, offering a direct window into prehistoric ecosystems. Consider Ötzi the Iceman, discovered in the Alps, whose 5,300-year-old body was so well preserved that researchers could study his clothes, tools, and even his last meal, offering an unparalleled insight into Copper Age life. In polar regions, ships lost to the frigid seas have been found centuries later, their wooden hulls remarkably intact, their cargo still identifiable, protected by the cold depths. These are but fleeting examples, however, of a process working on a far grander scale in Antarctica. The continental ice sheet is not just a patch of permafrost or a mountain glacier. It is miles deep, stretching across an entire continent, a vast, stable repository. If life, or indeed civilization, flourished there before the deep freeze took hold, then its remains, its structures, its very essence, could be preserved with a fidelity unimaginable in any other environment on our planet. The challenge, of course, lies in penetrating this colossal vault. The ice is a formidable guardian, often several miles thick, shielding its contents from conventional exploration. But humanity's ingenuity is rising to meet this monumental task, developing technologies specifically designed to peer through the opaque depths and search for what lies beneath. One of the most critical tools in this quest is ice-penetrating radar. These specialized radar systems are mounted on aircraft or ground vehicles and send radio waves down into the ice. When these waves encounter a change in density or material, such as a rock formation, a subglacial lake, or potentially an artificial structure, they bounce back, creating a detailed profile of the unseen landscape below. We have seen how early applications of this technology have already hinted at unusual patterns, at shapes and alignments that defy easy natural explanation. As these radar systems become more powerful and more precise, their ability to resolve fine details beneath miles of ice improves, offering an ever clearer picture of the hidden world. Complementing radar is seismic imaging, a technique borrowed from the oil and gas industry, but adapted for the unique Antarctic environment. This involves generating acoustic waves, either through controlled explosions or specialized vibrator trucks, and then measuring how these waves travel through and reflect off the underlying bedrock and any features within it. Different materials transmit seismic waves at different speeds, allowing scientists to create incredibly detailed three-dimensional maps of subglacial topography and internal structures. If complex rectilinear patterns or material densities inconsistent with natural geology were to emerge from these seismic scans, they could provide compelling indicators of buried artificial structures, offering a form of subterranean ultrasound that reveals the hidden architecture of a lost world. Yet, even with detailed maps, direct access remains the ultimate goal. This is where advanced drilling techniques come into play. Traditional ice core drilling is slow and cumbersome, designed to extract narrow cylinders of ice for climate research. However, for archaeological purposes, something far more ambitious is needed. Future drilling systems could employ hot water drills, capable of melting pathways rapidly through the ice, or advanced laser drills which could precisely vaporize ice, creating wider boreholes for deployment of instruments. Such technologies would need to be designed to be ultra-clean, preventing biological contamination of any ancient environments they penetrate, a critical ethical and scientific imperative. These drills would allow for the deployment of specialized remote-operated vehicles, or ROVs, into any detected subglacial lakes or voids. These ROVs, designed to withstand extreme pressure and operate in near-total darkness, would be equipped with high-resolution cameras, sonar, chemical sensors, and robotic manipulators. Their mission: to navigate the murky, cold waters of subglacial lakes, exploring the lake beds, the walls, and any features that rise from the abyssal darkness. Imagine an ROV gliding through an ancient, lightless lake, its powerful lights illuminating not only unique extremophile ecosystems, but perhaps also the silhouette of a structure, an intact wall, or a piece of technology lying undisturbed for millions of years. For areas not submerged, micro ROVs or borehole cameras could be lowered into melted channels to conduct visual inspections or collect samples directly from buried structures. The very concept of accessing and investigating deep ice in Antarctica, however, is fraught with immense logistical and technological challenges, pushing the boundaries of human endeavor. Antarctica is Earth's coldest, driest, and highest continent, a place of unparalleled remoteness and hostility. Simply transporting equipment and personnel to the interior of the continent requires massive resources, specialized aircraft, and months of careful planning. Temperatures plummet to 80 degrees Celsius, winds howl at hurricane force, and whiteout conditions can last for days, making any outdoor work perilous. Powering sophisticated drilling and ROV operations in such an isolated environment demands robust and reliable energy sources far beyond what traditional generators can provide. Furthermore, the sheer scale of the operation is daunting. Drilling through miles of ice is slow, expensive, and technically complex. Any malfunction deep beneath the ice could mean the loss of invaluable equipment and years of effort. Beyond these environmental and logistical hurdles, there are significant technological barriers. The sensors need to be sensitive enough to distinguish between natural geological formations and subtle, eroded hints of artificiality. The drilling mechanisms must be precise, powerful, and sterile to prevent contamination. The ROVs must be able to operate autonomously for extended periods, navigate complex, unknown underwater terrains, and transmit data through miles of ice to the surface. And critically, all instruments must be built to withstand the extreme cold and pressure, functioning flawlessly in an environment utterly alien to human design. These are not minor obstacles. They are some of the most profound engineering challenges facing modern science. Despite these challenges, the potential rewards are almost unfathomable. If the ice sheet truly guards the remnants of a lost civilization, then the discoveries awaiting us could redefine our understanding of history, life, and intelligence itself. The ice could preserve intact structures, not just crumbling ruins, but perhaps even sealed domes, fortified tunnels, or vast subterranean complexes protected from external decay. Such structures might still contain artifacts, tools, devices, or even records crafted from unknown materials, or familiar ones preserved with impossible clarity. Imagine unearthing a functional object, perfectly preserved, hinting at technologies beyond our current comprehension. Perhaps even more profoundly, the ice could preserve biological remains. If the civilization left behind any organic materials, from textiles to food stores, or even fossilized or frozen remnants of its inhabitants, the cold, a noxic environment offers the best possible chance for their survival. We could find genetic material, DNA, or its equivalent, allowing us to understand the biology of a species that arose on this once temperate continent. Such a discovery would not only confirm the existence of a highly developed civilization, but could also open entirely new avenues of scientific inquiry into evolution and extraterrestrial biology. The ice, then, is not merely a frozen barrier. It is a meticulously sealed archive, waiting for the right key to unlock the most extraordinary chapter in Earth's hidden history. It demands not just our curiosity, but the full breadth of our scientific and engineering might. The discovery of artifacts, structures, or even biological remains preserved beneath Antarctica's vast ice sheet would not merely rewrite textbooks, it would shatter the foundations of human understanding, forcing us to reevaluate our place in history and the very nature of civilization. If proven, this hidden past would trigger a cascade of profound impacts across every field of human knowledge, from archaeology and anthropology to philosophy and future planetary science. Our current historical timeline, which traces the rise of complex societies back only a few thousand years to Mesopotamia and the Nile, would instantly become a mere footnote in a far grander narrative. We would be confronted with the undeniable truth that intelligence, culture, and advanced development are not unique to our present era, but have potentially manifested and vanished countless millennia ago on our own planet. This revelation would fundamentally reshape humanity's perception of itself. For so long we have held a foundational belief that we are the first, the pioneers of complex thought and technological progress on Earth. We trace our lineage from rudimentary toolmakers to master builders, from hunter-gatherers to architects of global societies. But an Antarctic civilization, existing in deep antiquity, would mean we are not the originators, but inheritors. It would imply that the story of conscious, organized life on this planet is cyclical, perhaps even longer and more intricate than we ever dared to imagine. The question would no longer be if civilization can rise, but how often it has risen, and why its echoes have been so thoroughly silenced. Are we merely rediscovering a forgotten chapter, or are we carrying forward a legacy whose true beginning lies buried under miles of ice? This shift from being the first to being the latest would infuse our collective identity with a humility and a profound sense of connection to a past that predates all recorded memory. Beyond reshaping our historical self-image, such a discovery would offer unparalleled insights into some of the most critical challenges facing our world today. An ancient Antarctic civilization would have undoubtedly navigated dramatic shifts in planetary climate, As we discussed earlier, the continent transitioned from a lush, temperate land to its frozen state over millions of years, culminating in rapid glaciation. Studying the engineering, resource management, and social structures of a society that endured such profound environmental change could unlock invaluable knowledge about planetary resilience. How did they adapt to the onset of an ice age? Did they develop technologies for climate control, resource scarcity, or long-term survival in increasingly hostile conditions? Their experience could serve as an ancient case study, offering blueprints for future survival strategies that are desperately needed in our own era of accelerating climate instability. It might reveal unexpected pathways for harnessing geothermal energy, creating self-sustaining underground environments, or managing water resources on a continental scale, providing practical lessons rooted in a long-lost wisdom. Philosophical considerations would also ripple outward from such a find. What constitutes intelligence and civilization would be re-examined, stripped of our anthropocentric biases. We tend to define these terms through the lens of our own development, tool use, written language, complex social structures. But an ancient civilization, evolving in a unique Antarctic environment, might have expressed these concepts in forms we barely recognize. Their architecture might have been entirely subterranean, their communication methods non-verbal, their technology based on principles fundamentally different from our own combustion engines or digital networks. The universal laws of rise and fall, the inherent fragility of even advanced societies, would become starkly evident. Did this civilization collapse due to a sudden catastrophe, the slow creeping grip of the ice, or an internal societal failure? Its fate would serve as a powerful cautionary tale, echoing through the vastness of time, reminding us that even the most advanced societies are not immune to decline and disappearance. It would force a deeper contemplation of our own trajectory, making us ask if we are destined to follow similar patterns of ascent and eventual erasure. Yet with the monumental promise of discovery come equally immense ethical dilemmas. The very act of unearthing such a past would be fraught with complex questions. How do we approach the remains of a civilization, especially if its origins are unclear or its biological makeup alien? Is there a moral imperative to preserve the environment surrounding the find, a pristine ecosystem that has remained untouched for millions of years, even if it means limiting access to invaluable historical data? Contamination is a paramount concern. Introducing modern microbes or pollutants into an ancient, isolated environment could destroy unique biological traces or corrupt samples critical for scientific analysis. The potential impact on existing subglacial life, if any is found, would also need careful consideration, demanding a delicate balance between exploration and preservation. Furthermore, if artifacts are discovered, who would claim ownership? Are they the heritage of all humanity, or do they belong to the continent itself as a global trust? The very concept of repatriation takes on an entirely new meaning when the people to whom the artifacts belong vanished millions of years ago, leaving no direct descendants. Establishing international protocols for the ethical discovery, study, and protection of such an unparalleled archaeological site would be crucial, requiring unprecedented global cooperation. The logistical scale of an archaeological effort under miles of ice would be staggering, far exceeding any terrestrial excavation. Drilling into deep ice, maintaining stable subterranean environments, and extracting delicate artifacts without damage would push the boundaries of engineering. The sheer cost, resource allocation, and sustained scientific collaboration required would necessitate a unified global effort, transcending national interests. Moreover, the psychological impact on the explorers themselves, the first humans to stand in the shadow of a long-lost civilization, would be profound. They would be walking through a forgotten world, touching the remnants of lives lived and societies built in an era beyond human comprehension. This burden of being the first witnesses to such a monumental past would require not just scientific rigor, but also a deep sense of historical responsibility and awe. The implications for our understanding of evolution would also be revolutionary. If this civilization emerged from a lineage that evolved directly in ancient Antarctica, it would provide an entirely new branch on the tree of life, challenging existing models of species development and diversification. What unique adaptations would have arisen in a world facing increasing cold and eventual glaciation? Could intelligence, as we understand it, be a recurring evolutionary outcome under certain planetary conditions? If their biology shared no direct connection with known terrestrial life, it would force a re-evaluation of the universal principles governing life's emergence and complexity. Conversely, if there was a genetic link, it could suggest a common ancestor, pushing back the timeline of advanced life on Earth to an unimaginably distant past. The very definition of humanity might expand. If this civilization was not biologically human, yet displayed comparable intelligence and cultural complexity, it would broaden our understanding of what intelligent life can be. It would challenge our anthropocentric view that human-like characteristics are prerequisites for advanced society. This could have profound consequences for our search for extraterrestrial intelligence, guiding us to look for forms of life and civilization that might be vastly different from our own preconceived notions. It would force us to confront the humbling truth that the universe, and indeed our own planet, holds secrets that defy our limited definitions and expectations. The discovery would also ignite a fierce debate about the nature of deep time itself. We struggle to truly grasp spans of millions of years, often compartmentalizing history into neat, recent segments. An Antarctic civilization would force us to truly contend with the immense temporal gulf that separates us from such a past. It would highlight the impermanence of even the grandest achievements, demonstrating how effortlessly time and geological processes can erase entire eras from memory. The remnants beneath the ice would be a testament to not just an ancient culture, but to the crushing power of deep time, a silent reminder that our own civilizations, no matter how advanced, are but fleeting moments in the grand geological clock. Ultimately, the finding of an ancient Antarctic civilization would be more than a scientific breakthrough. It would be a spiritual awakening for humanity. It would force us to confront fundamental questions about our origins, our destiny, and our place in the cosmic narrative. Are we destined to repeat the patterns of rise and fall, or can we learn from a forgotten past? The ice, in its silent immensity, would then become not merely a barrier, but a vault containing the most transformative secret our planet has ever held. A secret poised to redefine everything we thought we knew about ourselves and the long, winding story of life on Earth. The journey into the depths of Antarctica, whether through advanced probes or the determined spirit of future human explorers, is not merely a quest for answers. It is a profound engagement with the limits of our knowledge and a re-evaluation of the narratives we hold dear. Even if no definitive trace of a lost civilization is ever unequivocally confirmed beneath the ice, the enduring power of the Antarctic mystery will continue to reshape us. It is the possibility itself, the haunting whisper of what could lie buried, that resonates most deeply within the human psyche. The continent, with its vast, pristine silence, serves as a colossal question mark at the very bottom of our world, an enigmatic presence that reminds us how reality often extends far beyond the neat edges of our current understanding. This perpetual mystery, a deep-seated curiosity about an unwritten past, ensures that Antarctica will never truly be just another landmass. It will forever remain a frontier of the imagination, a place where science and speculation meet to challenge the very foundations of history. Antarctica, in its icy grandeur, thus stands as a potent symbol of the vast, unknown histories hidden not on distant planets, but right here on our own Earth. For generations, humanity has charted continents, mapped oceans, and unearthed ancient ruins. believing that with each new discovery we gained a complete grasp of our planet's sprawling story. Yet this frozen landmass challenges that very certainty, suggesting that beneath its seemingly desolate surface could lie chapters of existence entirely unforeseen, perhaps even a complex culture that rose and fell in epochs long preceding our own recorded beginnings. It beckons us to consider the sheer scale of geological time and how much can be lost, forgotten, and yet miraculously preserved within the deep memory of a planet. This is not merely a localized search for a single hypothetical civilization. It is an overarching acknowledgement of the countless stories our world may hold, veiled by time, tectonic shifts, or, in this unique case, by miles of glacial ice. It implies that our current understanding of Earth's past, rich as it is with its detailed fossil records and archaeological finds, might only be a partial narrative, a small corner of a much larger, more intricate tapestry of life and intelligence that unfolded across billions of years. The saga of Antarctica's transformation, from a verdant land to its current icy tomb, carries with it a profound, undeniable lesson in planetary fragility and the critical importance of environmental stewardship. Whether a sophisticated culture flourished there, ultimately succumbing to its environment, or if only simpler life forms once thrived, the dramatic shift from a temperate, life-sustaining environment to a frozen wasteland underscores how delicate the balance of habitability can truly be. The immense geological and climatic forces that led to its glaciation, the inexorable march of continental drift, and the sweeping changes in global climates serve as a stark, timeless reminder of Earth's dynamic nature and its terrifying capacity for sweeping, irreversible change. If an advanced society did indeed exist there, its eventual disappearance, entombed by ice, could tell us a sobering truth about the ultimate resilience, or indeed the profound vulnerability, of any civilization in the face of overwhelming environmental pressures. This compels us to confront our own precarious relationship with the planet, prompting urgent questions about the long-term sustainability of our technological advancements and collective actions, and the potentially devastating consequences of a world pushed beyond its natural equilibrium. This frozen continent is not just a relic of the past. It is a potential prophecy for the future, a silent oracle warning against complacency and urging a deeper, more immediate respect for the intricate, interconnected systems that sustain all life. Ultimately, the quest for a lost Antarctic civilization is a testament to the enduring power of human curiosity, that unyielding, relentless pursuit of knowledge that constantly pushes against the perceived boundaries of the known. It is a fundamental reflection of our innate drive to understand not only where we, as a species, come from, but also where we stand in the grander, almost unfathomable cosmic narrative. We are beings compelled to ask, what if? To peer into the deepest shadows of history and to imagine possibilities that challenge our very definitions of time and existence. This insatiable drive is what propels explorers to the most remote corners of the poles, scientists to the cutting edge of their labs, and dreamers to ponder the infinite expanse of the stars. The search for a forgotten past beneath the Antarctic ice links us inextricably to the ancient astronomers who gazed at distant worlds with wonder, and to the tireless archaeologists who painstakingly uncover buried cities in distant lands. It places humanity within a continuum of inquiry, portraying us as a species forever seeking its profound origins and its true place within the universe. Whether the answer is a resounding affirmation of advanced life or a confirmation of ancient, untouched wilderness, the very act of asking, of looking, and of daring to imagine such monumental possibilities irrevocably expands our collective consciousness. It elevates our perspective beyond the immediate concerns of the present, connecting us to a lineage of seekers that spans not just generations, but millennia. And this leads us to the most profound insight of all, that the search itself, rather than merely the potential discovery, fundamentally redefines our understanding of time, of loss, and of the astonishing potential for life's myriad forms. The very act of conceiving of an Antarctic civilization, of developing the sophisticated technologies required to probe its unimaginable depths, and of debating the far-reaching implications of such a find, has already broadened our collective mindscape. It compels us to consider, with a new sense of humility, how easily history can be erased, how the inexorable passage of eons can reduce the most monumental achievements into indistinguishable geological features. This ongoing exploration of the unseen teaches us about the impermanence of even the grandest legacies, prompting a philosophical contemplation of loss on a planetary scale, a silent, almost preemptive grief for what might have been, or what might still be just beyond our current grasp. The potential silence beneath the ice speaks volumes about the fragility of existence. Moreover, the persistent effort to look beneath the ice reconfigures our perception of life itself. If a civilization indeed thrived in a once temperate Antarctica, it would extend the timeline of complex, societal life on Earth far beyond conventional estimates, hinting at a much deeper, richer planetary history than we currently acknowledge. It would mean that intelligence and organized society might be more recurrent, more resilient, and indeed far more varied than our current human-centric view allows. This expansive perspective hints at life's myriad forms, not just the biological diversity we observe in the present day, but the vast, almost unimaginable spectrum of how intelligence, culture, and technological advancement might manifest under radically different planetary conditions and across immense stretches of deep time. The continuous pursuit of this hidden past reminds us that life is not a singular, isolated event, but a persistent, adaptive force, constantly finding new ways to emerge, survive, and potentially even flourish in environments we once considered utterly impossible. It challenges the very definition of what is possible, what is plausible, and what is merely a matter of yet unveiled history. So, as the colossal, ancient ice continues to hold its secrets, the journey of discovery transcends the literal. It becomes a powerful metaphor for all the hidden histories of our world, all the forgotten possibilities that lie just beneath the surface of our immediate awareness. Antarctica, cold, vast, and eternally silent, ceases to be merely a continent on a map. It transforms into a living testament to the profound mysteries that still define our planet and our place within its immense, unfolding story. The echoes of its past, whether born of geology alone or of grand, lost ambition, will continue to inspire, to humble, and to drive humanity forward into the unknown, ever seeking the profound truths that lie buried, waiting for their moment to emerge and redefine everything we thought we knew.